technology, as we're going remote right now. Next up will be DJ Sampath from Armorblox. DJ is the CEO and founder of Armorblox, which stops targeted email attacks and outbound data loss by analyzing identity, behavior, and language. Today, he'll be talking about leveraging natural language understanding to strengthen security controls. Take it away, DJ.
Thank you so much, Vanessa, and thanks everybody for having me over here. Super excited to be here. Quick introduction. I'm DJ Sampath. Have spent a little while in the cybersecurity arena as being an operator of different in different roles. One of my the topics of conversation today. Let me share my screen to get my deck up here as well. Is basically to spend some time talking a little bit about what we at Armorblox sort of saw as a big inflection point in how we thought about controls for cloud office security. And cloud office security has become more relevant now than it ever has been. So with that, I'll love to dive into the context itself. When we think about cloud office security, and especially with more folks now being remote, it's become rather interesting how people sort of use these modern SaaS platforms, right? We're thinking about, hey, if you look at the cloud office today, the workforce is spread across so many different locations. They're using so many different collaboration tools, and the data over here is being distributed across each and every single one of these stacks. Whether you're talking about sharing a file that's being sent over Slack across Box, or being able to quickly put together a revenue report and share that on your Teams or OneDrive. It's sort of while this is obviously already in progress for a lot of companies, it sort of accelerated the process of transformation into starting to use some of these tools for a lot of companies that we're talking to on a day-to-day basis. Now, one of the things that we've observed that has been happening for the past few years is the nature of the types of attacks that we have been observing. These are getting transformed into something that is more targeted, that recognizes how people are working on a day-to-day basis, and it's socially engineered and focuses on something that seems really really normal, really mundane, and to some sense, in terms of the workflows that people do on a day-to-day basis. We see the challenges that some of the security teams face with being able to understand, hey, who's sharing this data? Are they supposed to be sharing this data, both internally and externally? And more importantly, thinking about lateral data loss across different channels. Like I mentioned earlier, taking data from one channel source and sharing that across to another data source. And so, as we talk to a lot of our customers or prospects and advisors, we learned very quickly that over 70 to 90% of all enterprise data is largely textual, and the security controls that are in place to understand this textual data was not very sophisticated. And there are reasons, really good reasons for those. Privacy controls in place that prevent machines or other people from reading data in itself. But the challenge really stemmed from a technology perspective in being able to have machines provide the appropriate context and take appropriate actions was something that was lacking. So to basically situate, what really changed in our capabilities or abilities to being able to understand this, I'd like to talk a little bit about this this graph over here. This is a benchmark score called the GLUE benchmark score, the General Language Understanding Evaluation, and the takeaway from this is how natural language understanding, which is basically an evolution of natural language processing, has gone through a inflection point, and so what you're seeing over here is a graph that describes the ability of machines to process a paragraph, a passage, and answer specific sets of questions based on what's been consumed over there. So if you were to think about this in a different way, if you remember your standardized tests, SATs or graduate record examinations, you would go through a reading comprehension test, right? You would read a passage and you would answer some questions. Machines go through those same things. Algorithms are put through those same things to see how well they perform. And a human baseline on a score of 1 to 100 is 87. An average college grad ends up scoring 87. Algorithms performed really poorly right up until 2017. They were in the low 30s and 40s. But in 2017, there was an inflection point there was a new technique called transfer learning that emerged. And now we are within a striking distance of being able to do just as well as humans. And internally inside of Armorblox, we've surpassed that score in being able to look at a passage of text and reason about it. We've got a great blog post about this that says, that talks about how Will Smith was wrong about the robots. If you get a chance, Google Will Smith and Armorblox, and you will land right there. The big takeaway from this is that now we have a tool that has the ability to look at a paragraph of text, reason about it, and say this looks normal or this looks anomalous. And being able to say that is a very powerful tool to have inside of your cybersecurity tool set. And so with that in mind, here's sort of a quick example of how we've been using this to be able to stop targeted attacks. So what you're seeing over here is one of the attacks that showed up very recently, a coronavirus fraud, which in which an email shows up from a domain that was registered rather recently, and says, hey, I know you're all working from home. This is the IT department. We've uploaded the policies to our OneDrive. It's important that you read these procedures and follow them, as a lot of things are changing. And classic phishing, zero-day phishing link that shows up and forces people to enter their credentials. What becomes important in this sort of an attack is not just hoping that you recognize that phishing link. More importantly, it becomes important to look at everything around it as well. It's important to recognize what the language and the intent of the conversation is. Being able to say, hey, the tone in the ask of what is being asked, of an end user to do doesn't seem normal. This is not something that comes from the specific domain. This is not part of the company. Being able to say that, hey, the frequency domain distribution is low. We've never seen communications before. It becomes important to combine all of those signals and be able to reason about the email that's coming in. Now, classically, these attacks don't get stopped by the secure email gateways. And so it becomes a challenge because they're looking at emails that are coming in a single shot, and being able to do some more data science that allows you to go back and forth becomes incredibly helpful in those situations. One more example here, which just broke the news of, we just announced it earlier today in the morning, and this happened as recently as a couple of days ago. There's a new attack that's going out there that pretends to be an email from Bank of America, and it basically just shows up that says, hey, your email is from a public SaaS service provider like Gmail or Yahoo.com. If you've not used this email address in a long time, you might want to make sure that you update your email address inside of Bank of America's portal, blah, blah, blah. It goes into those details. When you click into those links to update it, takes you to a perfectly good looking, Bank of America website, which really is not Bank of America when you look into the URLs. But if you shorten those URLs, it seems like Bank of America. And we saw a ton of activity on that domain, which meant that people are actively going to that and engaging with that domain. So the way now it becomes really critical to not just inspect that URL, because yes, we can do some computer vision techniques on the login pages and whatnot, but leveraging language here to notice that, hey, Bank of America in the past 6 months or past 12 months have never requested you to do something like this. This is absolutely unique, and it seems really suspicious because it's asking you to do something that's really unusual. Being able to extract that context using language, absolutely is a game changer when it comes to being able to detect fraud. At Armorblox, we're combining not just language, but also the behavior and identity signals. And this allows us to now have a 360-degree telemetry in terms of what we're seeing, whether it's, is it coming from the right, email device, right email client, right device? Do they normally talk about wire transfers? And of course, lastly, do they, what are the topics of communication that happen both inside and outside of the organization? We use a variety of different techniques to be able to compute that, and we're able to detect targeted, payroll attacks, payment attacks, vendor compromise, where your vendor gets compromised and sends you an invoice with a different bank account information, resulting in a vendor email compromise and more targeted credential phishing. The one, if I were to step back and talk about my past experience for the past 3.5 years, I got into this thinking that credential phishing is a solved problem, right? My initial skepticism was like, I don't think this is really a problem. I thought this is solved. This shouldn't be a big deal anymore. What's been, fascinating and a little bit depressing, if you will, is that credential phishing is still the #1 attack that's on top of mind for a lot of security team members and CISOs. And most of you here are probably already aware that north of $30 billion is being lost in email-initiated compromise. AIG, which does huge amounts of cyber insurance in the insurance landscape, talks about more than 28% of their claims that they are that they are working on are email-initiated compromises. So when we started digging in deeper, we recognized that most of these are not just simple phishing links or malicious attachments. These are socially engineered attacks that that look like a vendor fraud or a payroll or payment fraud. Somebody accidentally sharing PII, PCI data when they shouldn't be sharing that because somebody managed to coax that out of that person. So this is sort of what we have gone out and solved for based off of our platform, which is obviously covered, which is language covered. And so one of the things that we've done in addition to that is to help the SecOps teams remediate this situation, because they're looking at, we're at a customer where about somewhere between 350 to 400 emails are reported using the the KnowBe4 tools or Cofense tools, which are reporting tools that they've invested in. Those emails still show up to the to the security team's mailbox, and they have to perform that review of those many emails every single day. And this can be really stressful, because there's a timeliness associated with this. People have to quickly triage, north of 400 emails every day, and say what's suspicious and what's not. So we made their lives a lot easier from a SecOps perspective, and trying to auto triage this, automatically, make recommendations and take actions based on the severity of the emails. We mark them as safe if they are benign. We delete them and quarantine them, if that's what's required. One last piece here before I dive into the Q&A part of it. Hopefully I have the time. Is when we set out to build the core part of the platform, the language-based platform, we recognize that we have the ability to also expand our use cases to being able to help security organizations go beyond just detecting threats that are inbound. We wanted to be able to help them with the type of data that they're sharing, both inside of the company and outside. And so we were able to augment the native data security that a lot of companies implement by giving them, again, a very unique capability, which is going beyond keyword-based classification and signature-based classification of data inside of their environment. Now, what does this mean is, for instance, if you were to have a document that contains confidential data, for instance, in this case, it's an SEC or an S1 filing, and you want to be able to protect that document, even if people copy paste parts of it or are still talking about it in public channels, it becomes incredibly hard to construct all possible keywords and construct regular expression policies for those. So classically, a keyword-based detection or keyword-based classification for any textual information is very high on on the recall part of it, and the signature-based ones are very high on the precision part of it. But what we have built is something that looks at the topics, extracts the appropriate topics, and builds models that make it easy for people to implement data security. That's a little bit about Armorblox. I will pause here because I know we've got about a minute, and I'm keeping my eye on the questions section. So if there are any questions, please feel free to ask or reach out offline. We'll be more than happy to answer them for you.
Hi, DJ. We have a question from Barry Weber. You have about a minute, but he says, I believe that AI/ML is the future for everything security. What are you finding with respect to measurement of false positives and false negatives for your product?
That's a great question. If I were to tell you that there are no false positives, I'm selling you snake oil. AI and machine learning are probabilistic systems. They are not definitive systems, so which means there are going to be false positives. The best way, the best systems that we think work and are most effective is if you have a really tight loop in being able to get that feedback, either from the end users or from the admins, and rapidly adapt your models and retrain them to be able to effectively not show them again, or find similar attacks or similar patterns, and drastically drop your false positive rates asymptotically. That's the only answer. And in our false positive rates, we try to keep them really, really low by doing a whole lot of different techniques to mitigate that.
That was great. Thank you so much, DJ. I'm sure